It's a very simple truss example that we can start with here. This is a truss because all of the forces, I've got forces applied at the reactions here, A and C, but those are applied at the endpoints. I've got a force applied here at the endpoints, so all of these members only have forces applied at their endpoints. Therefore, we can treat each one of these as attached by a smooth pin, and therefore two force members. Each one of these is going to be a two force member, either in tension or compression, and that's what the problem is asking for. Whenever a problem says find the force in each member, it's normally a really good candidate for what we said, the method of joints. And so we're going to apply that here. Now the method of joints, if you go back and look at it, we just mentioned that. Step one, solve for reactions if possible. So let's do that. Free body diagram of the entire thing. We're just going to draw a simple frame of it. It doesn't have to be detailed. Apply forces to that. Right? Free body diagram of A, B, C. Entire thing. So just draw a rough diagram of A, B, and C. Apply forces to it. I've got this applied force, 500 newtons at the top. I've got a pin down here. So right now it's just a chapter 5 problem. I've got a pin down here, so it's going to have AX and AY applied to it. You can say, hey Steve, wouldn't you draw that in the negative direction? Yeah, you could. I wouldn't argue with you if you did. I've got a roller on a horizontal surface, so that's going to apply a vertical normal C. And the distances required for the moment equation are going to be 2 meters vertically and 2 meters horizontally. And we should be able to solve that free body diagram now. So again, at this point it's just a chapter 5 problem. Sum of forces in the x direction, set that equal to 0. That's going to be AX plus 500 newtons. I'm going to pause and solve this. So go ahead and pause and find those reactions and then come back. Okay, so you need to be able to do that, and you want to be able to where you can do it pretty quickly. You want to get in the, there's a reason I've been harping on you guys about draw your free body diagrams, set up your equilibrium equations. Can you solve? If you can, solve them. If not, draw your next free body diagram. That is exactly what we're going to do the rest of the course, and that is exactly what we're doing here. Notice, this doesn't even get us to our answer, right? We want to know the force in each of these things. That's not even none of these are this, but we need to find these in order to find these. So this is a step. And if you're like, Steve, well, I don't want to do all these steps to find stuff I don't even need. Well, that's how a lot of this works. I think I mentioned when I introduced this to you guys and said, well, you go through this process, and if you can solve, then you solve. And if you and you don't complain about the algebra, you don't complain about how hard it was, you don't complain about how much work it is to get there. This is engineering. There are plenty of other majors where you don't have to do a whole bunch of stuff to get to an answer. But this is what we do, right? So we've got some things that we need. It's not what is required. Let's go get what's required. So again, if we go back and look at method of joints, solve for reactions if possible. Okay, done that. We were able to find the reactions. Draw a free body diagram of a single joint where we have at least one known force and no more than 2 unknown forces. So if I look, I've got 3 joints I can pick from. 1, 2, 3. 3 joints I can pick from. All 3 of them, so right now I've got, I have AX and AY at this point, and then I've got a force in AB and I've got a force in C. So there's 2 unknown forces in these members here. But I do know all the reactions here, so I have at least 1 known and at least 2 and no more than 2 unknown. Same thing at any one of these. Every one of these joints, at this joint I've got the unknown reaction. I've had the known reaction. I have 2 unknown forces in these 2. And here I've got a known applied force and 2 unknown forces in those members. So I could draw a free body diagram of any joint you like and solve it. I'm just going to go in order because it doesn't appear that any of them are going to be easier than the others. So I'm just going to draw a free body diagram of point A. Now this is a free body diagram of a single point, a particle if you will. So I'm not going to be able to write a moment equation with a joint. I'm only going to be able to draw all the forces that are acting on it. So what's acting at point A? Well, I've got a pin here, and I've just found that pin has AX and AY acting on it, and they're both acting in the negative direction. So I've got 500 newtons acting in the negative X direction. Steve, why are you drawing it like that? Well, remember, I drew it positive here. I found it to be negative there. So I'm going to apply it in the negative X direction here. Same thing with AY. I drew it positive here. I found it to be negative 500 newtons. So I'm going to draw it in the negative Y direction there. And then what else do I have applied at point A? Applied at point A, I've got force in this member AB here. And this member is vertical. It's drawn vertically. So I'm going to draw a vertical force, and I'm just going to call it AB. And the same thing, I've got the force in this member here. From A to C, it is horizontal, so I'm going to draw a horizontal force AC. Note, if a member force is unknown, good practice to draw in tension. If I get a negative sign, tells me it's compression. I've drawn these two members as pulling forces. Tension is where it's pulling, so I've drawn these in tension. I'm going to solve for the unknowns, and if I find them to have negative values, which I don't think I will in this one, but if I find negative values, that just tells me that they are not actually in tension, they're not pulling. If I get a negative value, it just tells me that, well, it's actually in compression, so it's actually pushing. So let's, this one's going to be pretty simple, looks like. Sum of forces in the X direction. All the forces in the X direction. Well, I've got, that's going to equal 0. I've got AC in the positive X direction. In the negative X direction, I've got 500 newtons. I set that equal to 0. That can solve that. Same thing in the Y direction. Sum of forces in the Y direction equal to 0. I've got AB going up, and I've got minus 500 newtons from the pin going down. So you can solve these. I don't even have to pause and let you solve it. Feel free to pause if you need to. No shame. Get these right. I'm trying to talk and write at the same time, which is not always good. So we've got both AC and AB are 500 newtons. It's good practice to put next to it, is it in tension? Or is it in compression? So if you put a T next to it, that tells us it's in tension. If you put a C next to it, it's in compression. If you don't put anything, that means we got to go back to the drawing, which is not good. This way, these are reportable results. Right, so we can box these in if you like. Underline them, make them easy for the reader to find. Okay. Now, remember this guy I keep pointing back to and say, remember the process. What are you looking for? So what did the problem ask for? The problem asked us to find the force in each member. I've got 3 members, AB, AC, and BC. I want to find the force in all 3 of them and state whether they're in tension or compression. So step 1 is, what are you looking for? Okay. I've not found everything I'm looking for. I've found AC and AB. I found 2 of the 3 things I'm looking for. What I'm looking for is AB. Right? So what I did, well, I went through, I found what was known, what laws, tools are useful. I needed to find the reactions, so I found the reactions first. Did I have everything I needed after I found the reactions? No. So I go back. What was I looking for? Well, I need those member forces. So, okay, well, what is known? If I go to joint A, then I can write equations at joint A. Does that give me everything I need? No, I still need BC. Okay, what are you looking for? Well, I'm looking for BC. Okay, well, what do I know about BC? Well, I need to either go now to a joint that's attached to BC. So I can either go to joint B or I can go to joint C. Dealer's choice. You can go to one or the other. They're about the same mathematically, looks like. I'm going to go to, this is lecture 11. This is page 4 of something. I'm going to go draw a free body diagram of joint B. Go look at our original diagram. B has member AB, member AC, and the 500 newtons attached to it. I'm sorry, member AB and member BC. So joint B, I have 500 newtons applied out here at the very top. I have, you can draw it here just like this as AB if you like. You could also say that's 500 newtons. It's in tension. I've drawn this in tension. So you can either label as AB simply and then just go back and say, well, what was AB? AB was 500 newtons in tension. Okay, that's what I plug into my equations. Or you can just call it 500 newtons. Those are, either one's fine. It's your diagram. Put it however you like. And then I've got BC. Now we need to know the direction of BC. Well, they didn't give me an angle, but I know some trig. I can do some trig, and trig tells me that this is a 45-degree angle. If you're not sure, pause it and figure out how we find this angle right here. Okay, so if we're good now that this is a 45-degree angle, again, that's one of those, well, what do you know? What do we need to know? Well, I need to know this angle. What's a way I can find that angle? Well, basic trigonometry functions would find that angle to be 45 degrees. So I have a 45-degree angle here. Right? Do I have everything I need? Well, I don't know. Let's write equilibrium equations. Sum of forces in the x direction. I have 500 newtons. And again, I don't know BC, so I've drawn it in tension. I've drawn it pulling on the joint. And part of BC is in the x direction. So BC, and I'm going to, as I've labeled it here, 45 degrees there, the x component is opposite of that 45 degrees. And I've drawn it in the positive x direction, so I'm adding it. So that's an equation with one unknown. I can solve for that. Sum of forces in the y direction equal to 0 is equal to, let's say I've got minus AB, and then I've got minus BC, and this one, as I've drawn it, is cosine 45 degrees. Now remember, you can write AB or you can write 500 newtons in there, but either way, right now it's pointed in the negative y direction. All right, pause it and come back and give me values. Okay, you get it? I've got minus 707.1 newtons. Now, what you could do is, there's a few ways you can do this. You could say, well, that is 707 newtons in compression, and just underline that or box that in. That's okay. What you might consider doing, what would be really good for me and for you and for anybody that's viewing this, is just now collect all of the answers, because there's going to be problems where you're going to have more than just 3 members. So at the very bottom, or maybe at the very top, after you've collected all your answers and done all your calculations, just make you an answer block. And somewhere, just put all the forces, state whether they're in tension or compression, collect them all together, and it makes it real easy on both of us when you're going back to study this or when I'm grading it. And then write all of them through. Do not give me minus 707 newtons in compression. That is wrong. You're saying that that's 707 newtons in tension for BC, which is not correct. It is 707 newtons in compression. So do not call it minus 707 compression. Don't say it's minus 500 in tension or minus 500 compression. No. If you're giving me T or C, you do not need to give me the negative sign. That's what the T or C is telling me, the direction. And that's really what we need to know. That's what the problem's asking for. Is find the force in each member, state if they're in tension or compression. So this is a nice kind of uniform way to present that information. And notice how I've set this up. We talked about this the first day. Draw your problem, a rough diagram from the problem, mention what you're looking for. I've given a lot of detail here. You could write a little shorter if you like to. And then very clearly show how you've gone through the process of finding how those solutions break out. Right? And go through, and if it's in a nice, clear, methodical progression. And as you guys have seen, I'm going to grade your homework. If you're just copying it straight out of a solutions manual, no thought to how it's structured to progress, I'm hoping you guys are starting to figure out that doesn't help you for the exams. You're welcome to do it. It makes my grading easy. But this also makes my grading easy, and it's going to make your studying for the exams easy. And it's going to make you actually prepared for the exam. So when you get this problem, you have no idea how to do it without a solutions manual, then I mean that makes my grading easy too. It's not going to make your grade easy, but it makes my grading easy. Anyway, hopefully that helps. We'll pick up and move on from there.